Okay, as I mentioned, today's topic is PoetRAT. It is a newer threat that we did discover during 2020, but we've already actually seen multiple campaigns, some evolution and some development. With that, I'm going to go ahead and hand it off to Warren.
Thank you, Nick. Good afternoon, good morning, or good evening, depending on where everyone is. Thank you very much for joining us today. As Nick mentioned, I'm going to be talking about PoetRAT today, and some of the campaigns that we've seen out through 2020 will be covering the evolution of the malware and what we discovered earlier on in the year. So to give you a bit of an idea about me, as Nick mentioned, he's a security researcher with Cisco Talos. I'm the same. I hunt around APTs generally. That's basically nation-state threat actors. I essentially try to focus on the APT side of the house. I see things here like Olympic Destroyer, VPN filter, Do Not Fire sorter that we covered earlier this year. Obviously PoetRAT we covered this year. Things like DNS espionage and other nation-state backed actors and malware. Myself, I'm a network security guy by trade. I now do a lot around malware analysis and obviously threat intelligence. So that gives you a bit of an idea about me. My details are there. If anyone wants to ask questions, please feel free. I will certainly come back to them when I can. So we're going to talk about PoetRAT, as Nick mentioned. Our beautiful graphics department have designed this rather stunning rat with a little feather quill to give us the idea of a poet in motion. So we thought that was quite cool, and that's the image we've been using for this. So what is PoetRAT? Essentially, it's a motivated threat actor with a very specific victimology. It is at its core a remote access Trojan. The observations that we've made this year are very specific victimology around the Azerbaijani government. We've seen some specific interest in the renewable energy sector, things like wind turbines, and some of the SCADA and ICS systems associated with them. It is a Python-based rat. There's a couple of modules in the original version, and this continues into the new version that we'll also discuss. What we see throughout PoetRAT's evolution is Azerbaijani government-themed maldocs. The reason why they're using Azerbaijani themed is obviously that's their victimology. If you can make your victim feel a little bit more comfortable with the document you're sending them or the imagery you're sending them by making them see things they're familiar with, such as Azerbaijani content or Azerbaijani context, then it will make it more likely that that user will be a bit more prone to opening things. So we're going to start off with the old campaigns. These are the campaigns we discovered earlier this year. So these ran from February to April. This covers the initial finding and discovery of PoetRAT. I'm going to talk you through the three campaigns quite briefly, and then we're going to go more in depth into the actual malware and the technical execution of it. So the first file that we started to see was around February 2020. It was a malicious doc that was called section_policies. This was a malicious document that was blurred out, as we see in a lot of attacks nowadays. What was a bit strange, though, is the coat of arms used is the DRDO, and that's the Defence and Research Department Organisation of the Ministry of Defence of India. So this is an Indian Defence R&D coat of arms, but we don't believe there was any involvement from India at all. We suggest that this is used purely because it resembles an official seal. So a user may be familiar with seals on documents, and with it being blurred out that they can't see it, they'll be a little bit more, as I said earlier, prone and susceptible to thinking this is a legitimate document. The next document we identified was C19.docx. Now, I don't know if you're familiar with what's going on in the world, but this is obviously related to COVID-19. As you can see, this was a malformed document in terms of the text and character sets that were used. This meant that the user was actually presented with what appeared to be a malformed document. However, the VBA that was running in the background that we'll discuss was not malformed. So this was some of the coronavirus information that we're also found linked to this. Again, this was called Azerbaijan Special. Again, Azerbaijani themed. This is an output from an Azerbaijani console from coronavirus.info. And again, this is another platform that had coronavirus related info. So we've got a certain amount of maldocs used along the way here. We've got politically interesting events and geographically interesting events in COVID-19 and coronavirus. And we've got documents that are namely relating to Azerbaijani platforms and Azerbaijani people. So these actually came along with a phishing campaign. And the phishing campaign, we were able to come back to the same site where the malware campaigns was hosted. So this was a phishing campaign for mail.gov.az. So this is the official government portal of the Azerbaijani government. So their users would be expecting this, and this would seem normal. This screen output would be what they want to see and what they want to log in. So this was used for further credential harvesting that PoetRAT used in its initial attack. As I mentioned, the documents and maldocs that we identified were also hosted on this platform. So this was actually gov-az.heroku app. So it was hosted on a Heroku app platform. And this is the phishing page that was used, again, for further credential harvesting. So what were we being delivered? Obviously, we're being delivered a couple of malicious documents, and that's the way it goes. That is what an actor will try and do. They will try and send you a lure document or some piece of compelling information for you to click and ultimately run in the background then their malicious platform and their malicious payload. So PoetRAT for us, well, it became PoetRAT because within the VBA code, so the Visual Basic code that we found in the macro, there was a lot of context relating to Shakespeare's sonnets, specifically sonnet 116. So this is I believe, a 300 or 400-year-old sonnet. We don't believe there's any specific reason that this was used. The reason why an actor would perhaps put common words or phrases and terminology in their malware and in their macros is that it makes it sometimes harder for analysis and for automatic detection tools to pick up because it looks normal and it looks like common words that are used. If you'll notice on each line, I'll just use my mouse and so hopefully you can see that. This means it's a rammed out comment, so it doesn't actually do anything. It's just a comment field, and this is how the actor is able to insert this phrasing. So as I mentioned, this was the Shakespeare terminology, the Shakespeare sonnet that was used. Again, we're not really sure what the real motive behind that is, but that is why we named it PoetRAT. So the dropper comes with a payload extraction mechanism initially. Now this is an old trick. This is a trick that we've seen time and time before where we see files that are appended onto the end of other files. We've seen this on executables. We've seen it on image files like PNGs and JPEGs. We've seen it on Excel files. We've seen it on doc files. We see this quite a lot, but what PoetRAT did this time, so they used an old trick, but in a new way. So the malware was included inside a zip file that was appended to this Word document. And for the macro to extract that zip file and read it, it had to read 7 meg of data off the end of the file. So you'll see here that we've got the 7 meg of data, but you'll notice that it reads it backwards. It reads it from the right. So it's actually reading the data backwards. So if you go to the bottom of the file and read up, and that will then be appended out to a new file. And in that file is called zip.data. And the zip.data is a 7 megabyte file that has a Python interpreter and all the necessary files required. It's not Python.exe that we've seen before. This is the full source code for the RAT that was included. So this actor has been quite interesting here. They haven't compiled Python and used something like Python.exe to then just send an executable out. They've sent a rather bloated file because it's a 7 meg zip file. It has a full Python interpreter stack included, which is a bit bizarre and not something you would see a lot, but it ensures then that everything necessary for that malware to run and for that malware to carry out its operation is included. So if you're lucky enough as a malware actor to get your file on a system and compromise that system with your malicious exe or your malicious doc, well, if you have everything with you, you don't need to worry about what's on the machine or if the machine's locked down in any way. So once the file's unzipped, we see an execution carried out, and that's everything ready for the RAT to go to work. So we start looking at the internals of PoetRAT and what it does. So an initial execution, it does a fairly basic and rudimentary sandbox check. So what this is carrying out here is it's basically assuming that all sandboxes that this PoetRAT will come across is 62 gigabytes or less. So essentially, if it executes and realizes that the disk drive of the machine that it's being run on is less than 62 gigabytes, it doesn't run. Very basic, very rudimentary. Most sandboxes nowadays are over 62 gigabytes, but this is an older style and an older method. Now, if the hard drive is bigger than 62 gig, it will then generate a random UUID, unique identifier, and then it will start to replace that inside the RAT source code, and then we'll start executing the actual RAT source code. The reason why the actor is generating a UUID is it means that the operator can actually indicate to the RAT if it's the first execution, who's running it, where it's being run, and they can then pay attention to it. You might notice at the top in line 33, you see a sys argument there of police. So what this will be doing is once you execute PoetRAT, it will look for the string police as an argument. Now, if this argument is passed, it will skip all initialization and all VM checks. So that essentially means that any persistency methods needs to have the argument of police. If there are no arguments or it's not police, it will perform all its normal checks and initialize the malware. So as I mentioned, if it determines it's running on a sandbox, either by file size or by checking for the other comments that we mentioned, it will actually overwrite itself entirely and rather interestingly leave itself as a file called license.txt, which is quite interesting because no one reads their end user license agreements or any other license.txt files that they find. And obviously if it is good, then it carries on as I mentioned. So this is the internal communication mechanism of PoetRAT. Within this Python stack that we've brought along in our zip file, we have a couple of processes, and two of the main stage processes are smile.py and frown.py, one happy and one sad. So one's responsible for communication with the C2, and the other's actually responsible for executing the C2 commands. The communication is all done via a file on the system, and that file is called abibliophobia23. So if you have abibliophobia.23, these two Python files will read and write from that file to be able to carry out and process commands that are executed from the C2. Now the C2 command and control channel will be communicated over TLS and port 443, so standard HTTPS methodology of talking to a C2. This will pass backward and forth C2 commands that the operator wants the malware to issue. We'll go over some of those commands in a moment. And ultimately, what we get to is an FTP data extraction methodology. So the actor has TLS communication to the C2 for command and control instructions that it wants to carry out. However, all the exfiltration in the first version of PoetRAT that we identified is via FTP. And the communication looks sort of like this, as I mentioned. You see the two main processes. On the right here, we've got the class called affine or affine, and this is essentially a very basic encryption mechanism that it's using to pass information backwards and forth to the C2. Now, if you read that, it actually reads out as a very basic ROP13 scheme. So it's character by character basis and character replacement. This just makes it harder for IDSs and IPSs to see known information or known data in network streams. So by using something, again, as rudimentary as ROP13, we can hopefully skip and avoid detection that way. So some of the functionalities of PoetRAT, I'll just pick a few at random. So we've got sysinfo. Sysinfo is used to gather information about the system that PoetRAT is running on. Once it gathers this information, it's written to a file, and that file can then be passed to and from the C2, as we mentioned. We've got things like compress. So of all the files that we've maybe obtained from this host, we can compress those files using a simp functionality. We've got copy files, screenshots. We've got pretty much all the major functionality of any RAT, and that is essentially compromise a machine, obtain some information, and then pass that information back to the operator. So we've got some things here like shot, upload, and download. So these actually have credentials that are required to talk to the FTP server, as I mentioned. These aren't hard-coded, and these are actually passed between the frown and smile Python files that we talked about through the bibliophobia 23 file. So this meant the C2 operator could pass a fresh FTP if necessary. That meant you could avoid detection of it. What you probably don't see here is we've no automatic persistency in place, but we do have a register command, and this allows the operator, if they wanted, to create a registry run key. And again, if you remember from a few slides ago, we want to put that with the parameter of police, and that means we gain persistency, skip all our VM checks, skip all our functionality checks, and just run and execute the malware. So PoetRAT, also in this 7 megabyte zip file it brought some post-exploitation tools with it. One of these was called dog.exe. You'll notice we've now skipped from Python to .NET. The rationale, I don't know, I'm not sure. Maybe the actor was more comfortable in .NET for some additional functionality. What dog.exe will do is create a file system watcher. And again, you can just see this on the left-hand side, the file system watcher classes that are discussed. And what this will do is exfiltrate any new file according to the configuration that has been passed to it from the C2. So you've got things here like file size max. So that's how big the file should be. Here it's 50 megabytes. You'll see there. You've got the working directory, and that's by using the concatenation of the base path and my path file, and that will put together where it wants it to go. So you'll see here it's C program data target _ dog. You've got upload type. So it actually has functionality built in for FTP and also email. However, none of the samples that we identified had email hard-coded into them. They just had the option for using that. We've seen FTP uploads. We've then got the FTP credentials required, so FTP password, username, URI, and then, as I mentioned, you've got the SMTP information for email use. So the binary here, as I mentioned, uses a file system watcher, and what it will do is generate an event each time a file is modified in one of the directories in the paths. So if you look at the paths variable underneath in the white just here, you will see that these are the files, comma separated, and paths that we want to look for new files and new events being carried out. So you'll notice it's things like downloads, documents, and desktop. So the desktop might be where I default save files to, document might be where my email default saves files to, and then downloads is where I download information to and from the internet. These will be particularly interesting paths for a threat actor because they will have documents and downloads that relate to either the information that user works on or works with. Maybe it has download locations of data that's private or internal data to that user. And then desktop is, I think for most of us, a general dumping ground. So you can get some interesting files there as well. So dog.exe is one of the post-exploitation tools that we identified. Some of the others that we've seen were browdeck.exe. This is actually a browser credential stealer. So again, what the actor could do here is tap into the browsers being used on the machine, and it could steal any credentials that were stored in there. On the top left, we've got viewmac.exe, and it's actually to take pictures from the webcam. So you get a live picture, a live image. On the right-hand side, we've klog.exe, and it's a keylogger, which writes all its files to system32.log. Now, system32.log may be something that you see as a normal user and just bypass it because you're sort of thinking, oh, it's a log file that relates to my system, so it's fine. But this is all the information that would have had. So it'll have your backspaces, your shifts, your characters, etc. So it'll have everything a user would need to understand what they're typing. We see some privilege exploitation tools in WinPwnage, and then Nmap to do network scanning. So the PoetRAT actor had the capability to carry out lateral movement if they wanted. They had the right post-exploitation tools with them to find out information of the user. They had a copy of PyPyCats, which is a Python implementation of Mimikatz, so they could have a credential stealer on the machine. So with these sort of 6 to 8 tools that PoetRAT has brought along with it, we now have the capability really to move everywhere and anywhere about this infrastructure. But then PoetRAT took a small holiday. So after we saw this in February, March, and April, we didn't see it again. It disappeared completely. We've seen no traces of PoetRAT in any of our telemetry. We've seen no samples related to it or pertaining to it in any of the corpuses that are out there that we use. So in summer, we guess they might have took a holiday. They might have had some time off, and maybe they didn't want to catch COVID. Maybe they wanted to top up their time. We don't really know what the rationale is, but they did come back again. And they came back in September. And what's interesting about this is it was pretty much in line with when the Armenia and Azerbaijani conflict of Nagorno-Karabakh basically restarted. And that was throughout the summer into September. This is a disputed region, and we can see that there are clear geopolitical tensions between various nations with Azerbaijan here. We see Azerbaijan borders Armenia and Iran, for example. It has borders with Georgia and Russia. So there's quite a geopolitical hot pocket around there. So then we started to see new campaigns in September, as I mentioned. Fun's over. PoetRAT was back to work. So in September 2020, we started to see a couple of new files that looked very similar to PoetRAT and had the same MO, the same modus operandi, and the same sort of coat of arms and blurred image type approach. This time, though, this one was called Sayaha, which I believe is the Azeri word for list. So again, if you're attacking someone who uses a different language set or a different dialect, sometimes using files with their name and their naming convention makes them a bit more comfortable and a bit more aware of, well, this looks normal, this is fine. We also seen another file called argument.doc. We now noticed that PoetRAT had sort of changed its game a bit. We had some new functionalities. We could split files and a couple of other small things that we could do that we'll discuss in detail in a moment. And some of the strings here that we start to see were removed or changed. So normally what can happen is a threat actor can read a report or a white paper or a blog from either Cisco Talos or another research group out there. And because we always try and provide indicators of compromise to basically let you guys be able to do some research on your own path and be able to protect yourselves, sometimes the actor will see those IOCs and they'll actually change them or remove them from that file or from that binary. And that makes it harder sometimes for us to track if we're using things like Yarrow rules. So we've seen this actor do that. We now seen the actor attempt to obfuscate their code with PyMinifier. And then we've seen a change in how the configuration was stored. And we've a couple of new files that we're going to talk about shortly. But again, notice the blurred out image in the maldoc and the Azerbaijani coat of arms this time. And then October. So we've now been through September and October with multiple new samples that we've been able to identify and be able to obviously put down and reverse engineer. This sample here actually claims to be from the State Service for Mobilization and Conscription of Azerbaijan. Now, if you remember the conflict that I just talked about, this could be something very normal for a user to receive because they may feel that they have now a conscription call and mobilization related to what is being carried out, or an official document that has interesting comments and interesting relations as to what's going to happen. We now also saw in this, the macro now has some Fyodor Dostoevsky passages, and this is from a book called The Brothers Karamazov. It's a modernization of Russia book. We also saw Python replaced with Lua to download the final payload and execute it. So Lua is not something that malware actors tend to use very often. It can be quite beneficial because it's very fast and it's very small. So we're going to have a look at the Lua output in a moment as well. Unfortunately, we were unable to get the final payload from the C2 this time. What we did get was a large text file that was full of expletive messages related to our team when we were working on this. So that basically showed that the actor was aware of the work that we were doing. The actor was watching us as we attempted to gain the payload information from their C2 and attempted to basically see what was going on in their infrastructure. So that the actor was well placed to know what we were doing at the time. So we've discussed finding PoetRAT from early February through to April, some off time in the summer, then some geopolitical tensions kicking off in September, and then we see the return of PoetRAT, and we see some files that would make you think it's related to the geopolitical tensions between Azerbaijan and Armenia. So we'll now come on to the evolution of that. So PoetRAT, obviously, as you've seen throughout, is largely using malicious Word docs. The reason that a lot of rats would use this is most users will have a method of executing a document on their host. And that might be via Microsoft Word, it might be via some other word processing platform. But as long as they can open a doc, then generally the macro can run. And then in this instance, they brought their own Python payload and interpreter with them. So the Python scripts were there to run their actions. And again, as I mentioned, the Brothers Karamazov by Fyodor Dostoevsky is basically what is littered through this document and this malware maldoc this time. Again, you'll notice the comment sections here, so this doesn't actually read or do anything. It's merely there to take up space. You'll notice a very similar setup, the command/C, copy multiple arguments, the public file, all the stuff that we've seen before. Again, you see the read from right. So again, we read from the bottom end of the file up. And again, stuff that we traditionally seen in the first instance of PoetRAT. So as I mentioned, it was largely similar, but we started to see this use of Lua. And this had hard-coded port and host information that were allowing the malware actor to be able to communicate to C2. The rationale for Lua, we don't really know. As I mentioned, it's generally faster and slower than some stuff, but there is no real reason for them to have done this, unless it was maybe a different actor writing this piece of the malware to now try and make it better at what it does. There would be maybe some less detection methodology for Lua and looking for Lua. But yeah, we witnessed some Lua usage to perform some additional tasks. We now also see PoetRAT trying to obfuscate itself and hide itself. So PyMinifier is a Python script that you can run across your own Python scripts to basically compress and attempt to obfuscate and encrypt those scripts. It actually has a really cool feature that fortunately this actor didn't use. Hopefully they're not watching this webinar and they use it next time. But with PyMinifier, you can use a switch called no Latin or no Latin context, maybe it is, or no Latin characters. And what that essentially lets you do is build your Python script with multiple different character sets and dialect sets. That makes analysis of that quite difficult because general analysis, things like Sublime Text or 010 editor and things like that, when you're trying to look at this stuff to reverse it and see what's going on in the file, they don't handle multiple instances of different character sets and right to left parameters the same way. So if they'd have used that, this would have made the reversing is a little more complicated. So they've tried to use this essentially to avoid detection via any string or YARA rules that we were maybe using or people were using for detection, things like that. And this is what it looked like. You'll see it uses base64 with LZMA compression as well. So how else did they evolve and change up? They started using multiple files for basically handling how they executed the malware. So we had this new file called constant.py, and this had some of the required credentials that we use to communicate with C2 infrastructure. We now also see here in the excerpt below that we're now using HTTP as well as FTP, which was used in the original. And the reason why they've probably done that is FTP traffic across a network generally is a little bit more unexpected than HTTP traffic. So with HTTP traffic, we can blur into the lines a bit better. We can try and remain undetected without really worrying our users or concerning people what we're doing or how we're doing it. A lot of tools will look for normal HTTP traffic and normal HTTP methods being used. Again, you can see send and retrieve download links and the usual type stuff that we've seen throughout. You'll see also the constant.host file. So this is taking information from the constant.py file to be able to download and obtain information. And the output generally was to try and exfiltrate information related to the user they had targeted and compromised. So that is essentially PoetRAT in a nutshell. We have an actor who's very specific about their victimology. They bring a full arsenal of tool sets with them to carry out all their full attack chain. As I mentioned at the start, they bring a full Python interpreter stack with them, with all the required files and source code with them. They didn't go down the normal, I suppose, more route that we would normally see, which is the Python DXE type approach. They had .NET infrastructure along the way there. They had multiple binaries. They changed the Lua with all different types of files along the way. What we also see is the actor wants to gain every piece of information that they deem important. So again, having things like downloads and documents, well, a lot of people might store their own personal information there, so maybe bank details or pictures of their children, things like that. So there was an attempt to gain as much personal information as they could, as well as the very specific information that they had went in for. So we've seen the adversaries target very specific and almost exclusively Azerbaijani organizations in both public and private sectors. They seem to have some specific interest around ICS and SCADA, and also the energy industry, particularly renewable energy and wind. We also seen them, they were trying to basically do credential harvesting from the Azerbaijani government officials, because we've seen that mail.gov.az platform being used to try and phish users. So we have a full scale of post-compromise activity. We've got credential harvesting activity. We've got exfiltration activity. We've got attempts to laterally move across networks and infrastructures, all to try and basically allow this actor to carry out their entire mission. We had the capability of taking a full live photo of the victim. We had a keylogger to gain everything we needed. We had browser credential stealers also, with things like Mimikat and PyPyCats. We monitor very specific directories. This generally signals that they want to exfiltrate certain information that they deem important or that they deem useful to their operation. We had, again, as I mentioned, pictures with keylogging. We basically had the full sweep. We could get any information that we basically wanted. And just to finish off again, we believe from what we've observed that this was very specifically targeted to officials in the Azerbaijani government. And thank you very much. As Nick mentioned at the start of the call, we do have a feedback survey here. We would appreciate it greatly if you guys could jump on there, fill that out, let us know what was good. Equally, let us know what was bad. Let us know if this format's working well, anything like that that you think you could pass back to us. And on that note, I will on-share and take any questions if we have any, Nick.
Yeah, we do have a couple. Thanks again, Warren. It's great content. So a couple of questions out there. Just kind of a general comment about rats. It does seem like rats are being really commonly distributed right now. We've been reading a lot about that lately, and Talos has done a lot of research into it so far in 2020. Do you have any insights into why rats are being so prevalent right now?
It's a difficult question because I mean, rats have been prevalent since the dawn of time. I mean, you go back to things like old trojans that we used to see, like Sub-7. Like, these are things that have been around for a long time. I think the beauty of a rat is you've got functionality that you can do pretty much anything you want with. I mean, with PoetRAT specifically, we had a full sweep, as I mentioned, of functionality all packed up into one single rat. We don't need to bring like additional frameworks or anything. I know in this instance, PoetRAT obviously had to carry out further operations, but the core rat itself had the capability of taking your picture, stealing your files, taking your credentials. It could do everything. I think that's why we see more and more rats being developed. I think actors have realized that the use case for a rat far outweighs the use case for bringing a framework.
Makes perfect sense. So you've mentioned PyMinifier used for obfuscation. You mentioned a couple of the post-exploitation tools with PyPyCats and things like that. Are you commonly seeing more and more open source tools being leveraged by actors, both on the crimeware side and on the nation-state APT side as well?
Yeah, absolutely, man. I mean, law bins, so living off the land binaries, people are bringing their own infrastructures now purely by compromising a Windows host and a Windows machine. Even things like Rapid7, Metasploit. We see Metasploit used by actors all the time as well. I mean, we've given actor a capability to carry out advanced actions and advanced tactics without actually understanding what they're doing. Generally nowadays, if there's a new vulnerability released for a product, within several days, generally speaking, we've got a proof of concept. Most actors don't need to understand how that proof of concept works, but they do need to understand, well, if I can use Metasploit, I can then use that to attack and then use it to laterally move or exfiltrate data. So I think, unfortunately, I think we've made it easier for attackers now. We give them a full arsenal out there, and I think that's good and bad. It's good because obviously the research side dictates that we're doing well and trying to be better ourselves, but also we give them an easy in.
Yeah, that makes perfect sense as well. So we've seen so far already in 2020, despite PoetRAT just being discovered in 2020, we're seeing it actively being developed and some evolution occurring already. Do you expect to continue to see that in the near and long term?
I think what we find most interesting with PoetRAT is that I think we can clearly relate this to geopolitical tensions in that region. A couple of days ago, there was some peacekeeping efforts made by Russia to sort of quell the geopolitical tensions in this region. We haven't seen any PoetRAT activity for probably a month now since we posted, but it will be interesting to see if it stays that way. It'll be interesting to see if those peacekeeping actions remain the same and the political tensions de-escalate. I think if that continues, then we probably won't see PoetRAT used again. As I mentioned, it's been very specifically used, and it hasn't been used a lot. We didn't find hundreds of samples or thousands of samples. We found a very low amount of samples, which again probably reiterates to how specific this actor was being.
Okay. We have one final question here. You know, if you're a CISO in an organization that's concerned with handling these types of attacks, are there any, high level advice or technologies or things that you would recommend that they undertake to help protect them?
Interesting question. So I think if I were a CISO, I'd be looking at where my infrastructure is, what it's doing, and what my important assets are within that infrastructure. And I know that sounds basic, but I think it's something that a lot of us forget. We need to actually understand what's going on in our own playground before we try and fence it off. And I think once we understand what hosts are important, then we can start to harden them better ourselves. So technologies that we provide, like AMP for EDR, may give a user the ability to have that sort of more effective response should anything happen, and let the user or the CISO in this instance understand what's going on in their infrastructure. Obviously, things like IDS and things like malware protection on the box, I think will always remain important. So I think we just need to go back to basics, Nick. Sometimes we get too saturated with having the latest and greatest product sets without sometimes fully understanding what we're actually trying to protect and what we need to protect.
Yeah, that makes perfect sense. One final question. You've mentioned Azerbaijan a lot in the targeting related to this. Have you seen any targeting outside of Azerbaijan to this point?
No, not related with PoetRAT. We've seen very specific individuals targeted and government agencies targeted. There were no, I suppose, people by the wayside attacks where we see maybe an outlier of a user that doesn't make sense or conform. We didn't see that at all. We've seen very targeted and heavily focused attacks.
Okay. With that, that's the last question we have. I want to thank Warren again for taking the time today to really go deep and explain deeply PoetRAT and how it works. Again, there will be, in addition to the link that Warren just put up here a minute ago, you'll be kicked to a WebAx survey as well. If you take a few seconds and fill that out, I'd appreciate it. There will be a recording of this available on our YouTube channel sometime in the next couple of days. Thank you again for attending, and everybody have a great rest of your week.
Thanks, guys. Take care. Thank you.